Okay, Euclidean geometers. On today's show, we take a look at similar triangles. Two triangles are similar if their corresponding angles are congruent. That's what makes two triangles similar. Now, when you were in high school, you proved similarity by angle-angle. And the reason you only need two pairs of angles and not three pairs of angles is that we are in a Euclidean geometry. And so the angle sum for every triangle is 180. So if you know that two pairs of corresponding angles are congruent, then by subtraction from 180, the third pair of angles must also be congruent. So if you can get in a Euclidean geometry two pairs of corresponding angles congruent, you've got similar triangles. That's not true outside of a Euclidean geometry. Some things we should consider. If triangle ABC is similar to triangle DEF, then AB over AC equals DE over DF. You would have learned this in high school as corresponding sides of similar triangles are proportional. And this makes sense. Corresponding sides of similar triangles are proportional. This makes sense. How do we prove it? Well, the two triangles are similar. If one of the pairs of corresponding sides is congruent, then we're done. So let's pretend that AB is bigger than DE without loss of generality. So let's pretend that AB is bigger than DE. If AB is bigger than DE, then we can make a copy of DE inside here so that AB prime is equal to DE. And then because angle BAC is congruent to angle EDF, there is a point C prime on ray AC that corresponds to F. Now, because corresponding angles are congruent, we know that this line is parallel to that one, and we've got transversals that hit both of those parallel lines, and so it must be, by the parallel projection theorem, that AB prime over AB equals AC prime over AC. This is the parallel projection theorem. AB prime over AB is AC prime over AC. But wait a minute, what was AB prime? That's what we got by bringing DE into the picture. And then where did AC prime come from? Well, that was the side that corresponded to DF. I'm pretty sure that a little bit of algebra is going to turn this into that. And we're done. And we're done. So if two triangles are similar, then their corresponding sides are proportional, and that's a big deal. There is another way to prove the triangles are similar. That's side angle side similarity, and that I'll prove in the examples video ahead. I'll also do one of my favorite questions from Regents exams since we're still spending time in high school. All right.